In 11.6, there's nothing new that is taught. The only concept that they are going to try to get you to think about is you've learned how to factor, you've learned how to complete the square, you've learned how to use the quadratic formula. But they want you to actually think about, if you have the choice to do those three different methods, which method would you choose and why? As a matter of fact, when I looked at your worksheet, these are the directions of number 1. It says solve one part by factoring, one by completing the square, and one by the quadratic formula. You are going to have to make a choice. Do I do this with factoring or completing the square or quadratic formula? And you're only going to get to do one for each. And so what I thought when I was making your notes is I go, how are they supposed to know that? So I decided to write these things out. Factoring is easy when things factor and they're whole numbers, but not everything factors. There's two methods to use when something doesn't factor with whole numbers. You can complete the square or you can use the quadratic formula. They both work. But how do I know which one to use? Completing the square is a little bit rough when a doesn't equal 1. Quadratic formula works for everything, but it's the longest amount of work. So here's what I recommend. If your leading coefficient is not 1, let me show you what I mean. I look in front of the x squared. If it's a 1, if it's not a 1, this is a 1, this is a 3, this is a 1, this is probably the one you're going to want to use the quadratic formula on. If there is a leading coefficient, usually that's what you're going to pick. If it factors easily, then you're going to choose factoring. If it doesn't factor and a is equal to 1, then complete the square. That's what I recommend. First half of the worksheet, you choose which method you want to use. And then the second half of the worksheet is about graphing. It's almost like they decided to bring back everything we talked about in chapter 10. Vertex form, standard form, intercept form, and intercepts. Like I looked and I found, oh, we taught that in 10.2. I taught that in 10.7. I taught that in 10.4. And I kept finding things that I've already taught you, but at the same time I thought, well, we know our last test average wasn't that great, so I had to bump it up a little bit, remember? So this is a good review for you. It's good for me to have you write it down because you can learn it over again. And remember, there are these things called ticket to retakes. You guys can do retakes on tests that you are not happy with your score on or that are holding your grade down by redoing certain questions and preparing yourselves for that test. So if you want to redo 10 after you get this stuff, that'd be awesome. What do we need to know? In vertex form, this is how you find the vertex, the axis of symmetry. Opposite, same. The axis of symmetry is there. Standard form, we can convert it into that form by completing the square. Intercept form shows me where it crosses the x-axis. Then we can find the axis of symmetry and so on. So I'll review this stuff as we do some problems down below. I have picked 3 examples because they'll take us some time. I picked number 1. And number 1 says, 1 part by factoring, 1 part by completing square, 1 by quadratic formula. The first thing I look for is which ones am I going to use the quadratic formula on? This one has the leading coefficient. I'm going to put quadratic formula is what I'm going to pick there. And then I'm going to have to complete the square on one of these, and I'm going to have to factor another one. So do I want to factor this one? Do I want to factor this one? What I need to do is I need to figure out if any of these times any of these will make that, or if any of these will make that. So if I'm thinking about factoring, I'm going 1 times 9, 1 times 1, that's not going to make a 4. 1 times 3, 1 times 3 is 3 and 3. That makes 6, does not make 4. This one's probably not going to factor. If I go over here, 1 times 5 and 1 times 3, 5, take away 3 is 2, I might be able to factor this one. So this is what I'm doing. I'm going to factor this one, and I'm going to complete the square on that one. Once you figure out what you're going to do, then you do it. Let's complete the square. Let's move the 9. Let's add 9 to the other side. X squared plus 4x underscore equals 9 underscore. Then I take b, half of b squared. I add to both sides. I'm adding 4 to this side. I'm adding 4 to this side. But this side factors perfectly. When you FOIL this out, it makes x squared plus 4x plus 2 squared. This side makes 13. And then we can now square root both sides, which there are 2 possible answers for this, a positive and a negative. When you have plus or minus root 13, that doesn't simplify. If it does, you do simplify it, but it doesn't. The last step we have to do is subtract the 2 and subtract the 2. We're going to put that minus 2 in front of that plus or minus. Negative 2 plus or minus root 13 for A is our answer. That's completing the square. We've been doing that a lot. The quadratic formula, though, we have to make sure it's in standard form equals 0. It does. Then we use opposite of b plus or minus radical b squared minus 4 times a times c is a negative 5 all over 2 times a, which is 6. That number's kind of big. So I'm going to figure out what 49 minus 4 times 3 times negative 5 is. I use the calculator to help me figure that out. It does not reduce. So my final answer, I generally will split these. This numerator divided by 6 and this numerator divided by 6 because I want to check to see if this reduces or that reduces, which it does not. But in case it does, that's why I do that. The last one is factoring, where you say what times what will give you this value, and I'm pretty sure if we chose the 5 and the 3 we can get there. Since I want a negative 2x and this is the O plus the I need a negative 5x and a positive 3x. The outside plus the inside should equal the negative 2x. The last times the last needs to equal the last number. Basically doing the opposite of foiling. And then once you have this times this equals 0, either the first group equals 0 or the second group equals 0. And you have to find what possible answers could there be that would make the x plus 3 equal 0. So it basically changes this sign. And same thing with that negative 5. X minus 5, how is that going to equal 0? It will equal 0 when x is equal to a positive 5. It basically changes that sign. Our two solutions are negative 3 and positive 5. So you have two other problems where you are going to have to figure out which method do I use and why. Look for the leading coefficient and complete the square and factor. The second example that I picked for you was number 9, because graphing, some of you need to review. How do we find the vertex of this? How do we find the axis symmetry for that? How do we find the x-intercepts and y-intercepts? So let's do a review. To find the vertex of something in standard form, we need to put it into vertex form. Let's complete the square. Let's subtract 3 to this side. Y minus 3 underscore. Then the a value is not a 1, so we factor out a 3 from both of these terms. A GCF, not a GCF, but a common factor, basically. And we're doing that so we get a perfect square, something times itself. Now, if I put the something times itself here, by going half of this squared, we can complete the square. I'm going to add 1 squared on this side. But we're not really adding 1 squared. We're adding 3 times 1 squared. So over here, I put the common factor. Multiply by what I put in that underscore for this left-hand side. That's what a lot of students forget. And then this side factors. This side has to simplify. 3 times 1 is 3. Minus 3 is y plus 0. And even though I don't need to do this, I'm going to subtract 0 just so you could see that y is equal to 3 parenthesis x plus 1 squared minus 0. And I did that because now it's in vertex form and I know opposite, same. Here's your vertex. Opposite, -1. Same, 0. There is no such thing as a -0. It's just 0. There's no such thing as a positive 0 for that matter. It's just 0. The axis of symmetry is the same thing as the x-coordinate. X is equal to -1. It's a vertical line. We write x is equal to. The y-intercept is the next thing that I would find if I were you, because it's the next easiest thing to find. The y-intercept, where it crosses the y-axis, x is 0. We just have to figure out what the y value is. If x is 0, look at how easy it is to figure this out. 3 times 0 plus x is 0 plus 3 is equal to y. I bet you if you plug 0 in there and there, you can see easily what it is when it's in standard form. It's the c value. And then the last thing are the x-intercepts. I would do this for the x-intercepts. X-intercepts are when the y values are equal to 0. When the y values are equal to 0. Let's figure that out. Let's plug in a y is 0 and then do this problem. Let's set the y as 0 in vertex form. Doesn't matter if there's a 0 there. I'm going to divide by 3, divide by 3. 0 divided by 3 is 0. I'm going to square root both sides. Plus or minus 0 is still just 0. And if I subtract 1, you're going to get your x-intercept. There's actually only 1 this time. Sometimes there's 2, sometimes there's 1. It depends on what this square root turns out to be. Which means -1, 0. This is our vertex. It's also our axis of symmetry. Our x-intercepts are at negative 1, 0. Our y-intercept is at 0, 1, 2, 3. So if you think about this parabola, opening upwards, there's your parabola. Which makes sense if you remember that the 3 makes it more narrow than what we used to have, than the normal graph. The last example that I have for you is number 10, because this is intercept form. We haven't done a lot of intercept form. I'm going to do this in a different way than I did the previous one because this one's already factored. Because it's already factored, it's easier for me to find the x-intercepts first. The x-intercept is when y is equal to 0. So the first thing I'm going to do is I'm going to say, well, what does x have to be in order to multiply to equal a y value of 0? This is that zero product property where this times this equals 0. Either this is 0, which it can't be, doesn't work, or this is 0 when x is equal to negative 2, or this is 0 where x is equal to 4. So I know where my two intercepts are, negative 2, 0, and 4, 0. It's basically opposite, opposite. I can go to my graph, put the negative 2, 0, and then 4, 0. I can put my two dots on the x-axis, and I know where it crosses the x-axis, which is what's going to lead me to find the axis of symmetry. The axis of symmetry is the thing that cuts this directly in half. 1, 2, 3, 4, 5, 6. So 1, 2, 3. My axis of symmetry has to be exactly in between these two red dots. I have to figure out where that is. That's at x is equal to 1. So I write that in for my axis of symmetry. Now I don't know where on this axis of symmetry the vertex is, but I do know that if I plug 1 into this equation, I can figure it out. So then I take this and I plug in 1. 1 plus 2, 1 minus 4. And I can figure out what is y when x is 1. Well, that makes 3. That makes negative 3. That makes negative 1/2. So multiplying, I get negative 3/2 times by negative 3 is a positive 9/2, or 4.5. Which means this graph, if I go to the right one and up 1, 2, 3, 4.5, that's where my vertex is. And I can think that my graph does this because it has a negative a value, which means it's going to open downward. The only thing we haven't done yet is the y-intercept. And so how do we find that y-intercept? We plug a 0 in for x. If I plug in a 0 in for x, it looks like this. 0 plus 2, 0 minus 4. Let's figure out what that is. Negative 1/2 times 2 times negative 4. That makes negative 1 times negative 4 is a positive 4. Which kind of makes sense because it means I cross 1, 2, 3, 4. That looks just like what I found in my drawing. Half of that is review. The other half is, I mean, the graphing is stuff that we did before, but you still need to remember it. The other half is which one do you choose using 3 methods you learned this unit. I'm going to stop your notes right there.